Thanks very much. More importantly, I'm going to be asking the question, can sewers be cleaned with ice? And I'm going to give you the answer, or part of the answer, straight away. Yes, some sewers can. What's so good about cleaning with ice, or what is cleaning with ice? When we talk about cleaning with ice, we need to think about an ice slurry. And ice slurries have got fantastic physical properties. They can be pumped, but they also can act as a solid. So where we've used this already is in water distribution networks, where we can introduce easily large volumes of ice, flooding parts of the network with ice through small orifices and existing fittings. It can flow around bends, doesn't get stuck. And as an example of its effectiveness, if you've got a column of ice that's around 200 meters long, you can clean a kilometer of pipe to about the same effectiveness as a swab. So I've got a series of videos here just to try and explain where we are in the process of developing a solution for sewers. But really this is a solution that exists primarily at the moment in water distribution systems. And I've had some problems with my video, so this wasn't the one that I wanted to show you originally. However, this is showing how, really giving an idea of how it works. This is a pipe that's got water in it, and now we're very slowly introducing ice. And the ice is a pumpable slurry, as I said before. And the important thing for us is we're filling the pipe completely, and you can just about see on the top of the pipe here that we've accidentally in the laboratory removed some what turned out to be biofilm on top of the pipe. So cleaning it with ice is an accepted technique now in water distribution systems, and it's becoming something that has, amongst water companies, some hope for pumping sewers. Let me talk to you a little bit about how we've got to where we are. In 2001, Professor Querini at the University of Bristol patented the idea of cleaning pipes with ice. Great idea. It was really invented with the food industry in mind. But it took him a couple of years to realise that there may be an application in the water industry, and that's where he approached his local water company. And in the years between 2005 and 2009, there were quite a series of experiments in making it work for the water industry. In 2009, it was accepted and recognised by the Water Industry Achievement Awards, and soon after that, the company that I work for took on responsibility for commercialising and providing a service, which is what we do now. We provide a service in the clean water industry to water companies directly. And of course, we won the IWA Project Innovation Award as well. So in water distribution networks, I'm not going to talk, this is the last slide on clean water. We've turned the idea into a commercial service, and we've got two offerings. And really, this is the scale of the operation here. We've got these big vehicles that deliver large quantities of ice with real benefits for water companies, because it's generally a far quicker process, uses less water, is much more effective, and the key one here, carries virtually no risk. And what we're seeing is in pumping sewers, that no risk situation is a real important thing, and an important driver for investigating whether pump sewers in particular can be cleaned with ice. And so we've got ice pigging down the bottom there. That tanker at the bottom of the slide carries 10,000 litres of ice. It's quite a lot. So, it works in the clean water industry. What about in the environment that exists inside sewers? So this is a video, and I apologise for the quality of it, but it's mayonnaise, and we're introducing green mayonnaise, so we can see it in the pipe, into a pipe to see how effective it is. You can see that it's horrible stuff, mayonnaise. Don't really want to eat it, but very viscous, very sticky, very, very difficult to remove with water, although I'm sure with jetting we could do. So what we're showing here is a pipe about 20, 30 meters long that's got some mayonnaise introduced into it. We're flushing it through, and no surprises, we're flushing through some mayonnaise. You can see it coming through in green, lumpy. But in a minute we're going to introduce some ice, and the ice actually clears the pipe, but also wipes away the mayonnaise. Now the difference here is that the strength of ice that we're using is far greater than the strength of ice that we generally use in clean water networks. If you imagine in a clean water network we're using something akin to a slush puppy, this is, you'll see it at the end, this is a much, much firmer ice, like compacted snow if you like. And here you can see it's completely cleaned that pipe out. We've got nice clean ice coming through. There it is, it's like snow. And that's where we see the difference with sewers, is that if we use a much stronger strength of ice, we get a much harder result. Does it remove anything else? Okay, we think it can remove viscous items, and I've actually got all sorts of videos about removing cat food and unpleasant things. But this is what we've actually removed from distribution water pipe, drinking water pipe. So we definitely know that it removes objects, and this was, I thought I'd throw this in as one of the examples of, it's a bit slow to start with, an example of a brick being removed from a pipe. But the key thing here is this is an open-ended pipe, it's not a pressurized pipe, so that's why it's a little bit slow, it's being pumped slowly. You can see the bricks in the bottom there. And this video is about 2 or 3 years old. I think it's one of the original experiments when the process was being developed. And you can see there that it's got the power to move those large objects. And it's been something that we've thought that there's an application here. It's just that it's not been anything that we've pushed at this stage. But this is a really good example, and this is a live example of how we cleaned a sewer, a pumping sewer, for Wessex Water. I'll talk you through it slightly before we start the video. So this is a 1.6 kilometre length of sewer, MDPE sewer. And the primary reason for cleaning this was because the pumps just weren't handling the load, because they had expected that it had become encrusted with fats. This is effluent from a dairy. And you see the answer there in the bottom about what the effect was. We did have a very good result. Oops. So that's the insertion point. That's where we inserted the ice. And again, I think we used 15,000 litres of ice, a very large quantity. We're filling the pipe to a large degree. And this is really just showing the effluent to start with. This is downstream. We've already started pushing the ice stream. You just about see the ice there. Now that picture is probably the best proof that what we've done is remove the kind of rubbish that you get from a pipe like this. The biggest challenge that we've got at the moment is to understand the effectiveness in a sewer, because as we're now learning, very difficult to take samples, or have to be very careful to take samples of what comes out of a sewer, which is part of our standard process when we're working in a distribution drinking water pipe. So here's the pumps, and again, very difficult for us to quantify the amount that's come out, but we're working from the result that the customer wanted, that Wessex Water wanted. They have seen a 30% rise in flow through that pipe from the same pump output. So we think that that's a really positive indication, that this has removed quite a large volume of material, and we remove quite a large volume of material usually in drinking water pipes. and that this has real application because it's very, very low risk. So I think we're now in a position to say that we think that in pressurized pipes, you can clean pipes with ice, and it's probably the most cost-effective, most efficient way of doing so. But with sewers, we need to gain more data on how to measure the effectiveness of that. It's a new area for us. But again, from an operational point of view, it's pretty straightforward. You pump ice in one end, and it comes out the other end. We do use the pressure of the pumps, if it's a pump sewer, to push the ice, but you know, there are other ways of doing that. So from a risk point of view, there is virtually none, because ice melts. Our aim is to do more work on pump sewers with one eye on gravity sewers. Now, the examples that we saw in the previous presentation are extreme, but we can see that the real benefits of using ice are worth investigating further. So the challenges we expect to have to face in gravity sewers, the key for us is how to push the ice. We really don't want to get any flow-up laterals. That could be quite damaging. And we expect that there will be some operational challenges. So we're very interested in talking to companies that have got experience in this sort of thing. So in summary, it's definitely an established technique for cleaning pressurized pipe networks, and we see that the real benefits are low risk, very low impact, extremely effective, and we're now saying it's the most cost-effective technique out there. But for pump sewers, the drivers here are it's virtually no risk. So inserting objects into that pipe to clean them that could get stuck is a risk. Having downtime on that pipe is a risk. So you don't have those when you're using ice. And the experience that we had was about a 30% improvement in pumping efficiency, which we think is fantastic. And the investigation continues for gravity sewers. So please come and have a chat if you have an interest.